So in my research I study bacteria and viruses, and bacteria and viruses don't generally grow in patterns like these, and I'll tell you a little bit about how they grow. They grow by dividing in two. So actually a mother bacterium, she looks a bit like this, she's kind of long and skinny, and she actually breaks into two to make two little daughter cells, and those daughter cells grow up and then they break into two. So we can represent that here. I've started this little tree. Here's the mother bacterium, and then she has had two daughters. These are her daughters, 1 and 2. And each of the daughters, when they grow up, they'll split and have two daughters themselves. 1, 2, 3, 4. And again, each of these will have two daughters. 2, 2, and 2 for this one. And then each of these in the next generation. So we've got 5 generations here. This one splits into these two, this one splits into these two, etc., all the way along. So we've built this whole colony of bacteria, and now I'm going to try plotting with my bingo dabber what sort of pattern this makes. So this will be the first column that I'm going to plot, and it just has one mother bacterium. And I'm going to have to start low because this will be a big pattern. So I'll put her right here. And then the next one has 2. And then the next one, the 2 doubles, I have 4. And then again we have a doubling, so we have 8 in the next column. And you can probably figure out what we're going to have for the next generation. Each of the 8 bacteria made 2. So now we have 8 times 2, 16. And just to be really impressive, let's do one more generation. So if we had 16 bacteria in the next generation, we'd have 32. That's 16, and now I'll do 16 more. Wow, it just fits on our page. And now if I tried to figure out what the slope of this growth curve was, if I tried to line up, remember here I could line up the top dot in each column and get a straight line. But here if I try to connect the top dots, I can't do it. I'm not getting a pattern that's a line. And instead, if we drew a line through here, we'd have a curvy shape. So it's a completely different growth pattern. Here we go. And this kind of growth is called exponential growth. It's really fast. Things start doubling, and this is actually part of why germs are dangerous for us, because once they get inside you, they can grow very, very quickly like this. We started from 1 bacterium, and now we've got 32 in very short order. And if we compare with this pattern over here, for example, we started with 6. We started with a much bigger, much higher starting point than we did with the exponential growth. But after just 5 generations, we weren't nearly as big as the green dots. So you can see that linear growth, even if you start at a high point, it's much slower overall than exponential growth. Exponential growth will catch up and take over. So imagine that this were money. This is another analogy we can use. Suppose your parents gave you $6 to put in your bank account 1 week. And then the next week after that, you have that $6, but they give you $3 more. And the next week after that, they give you $3 more and $3 more, and your bank account keeps building up. Then the money that you have would build up like this. But maybe your parents would offer to do that for you, or the first week they said, we're only going to give you $1, but every week after that, we'll double your money. So the next week, you'll only get $2, and the next week after that, you'll only get $4. You might think it would be better to start off with $6 and grow this way. But if you look at how much you'll have after 5 or 6 weeks, it would be better to double your money every week, even though you only started at 1 and 2 and 4 over here, and you got to start at 6 over here. In the long run, you're much better off if your parents agree to double the money they give you every week. In fact, you'll be very rich in short order. In fact, if your parents could keep going for 10 weeks, you'd have over $1,000 on this curve.